Okay, I guess we're live. Hello guys, I'm PJ and today we'll be learning about C. So this will be a 3-day workshop and let me just give you a brief introduction so we can see the screen. Zoom in a bit. This will be our final project for the third day. It's almost complete, though I have to do a few tweaks and let's just put a bit for the project. So this will be a shell. A shell is a basic program that allows us to interact with the operating system. Using the shell, and I have called it the DC shell. The DC is for design and code. So we're running command ls, which will show us the content in a directory. ls with the a flag, then it will show us everything that is in the directory. I haven't prepared any directory, so our final project, and as you can see, we can run the create command to display the content. All. Yeah, so let's get started. This workshop will be very beneficial for people who have some basic experience in any programming language. Uh, Mostly general purpose programming language or function parameters and then function programming has or something that then you can't easily follow along. But yeah, if you know any general purpose programming language, then you're good to go. Okay. Okay. So we'll be using this whiteboard. So the and also and make a directory for the workshop.
noise cancellation on
Noise cancellation.
settings नीचे notification on करो
On कर दूँ. Okay.
बोल
आ रहा है.
आ रहा है मतलब बीच में नॉइज आ रहा है समझ नहीं आ रहा
Okay. And sometimes I tend to speak very fast, but this bonus factor will go just stop me. Okay. So what I'm thinking is ये जो source code होगा, the source code we'll upload it on GitHub, not on the DC shell repo because that's exclusively for the project, but a separate repo called the C program. Okay, so this is basic C program, basic B program, the basic system that prints hello world. So GCC is the compiler, C, compiled programming language. So I guess everybody is familiar with the concept of compiler interpreted programming language. But still, for a quick revision, a compiled programming language is the one which generates build files. So if I just to check, then you can see there's a Okay. If you are familiar with Python, you'll data type like in Python or JavaScript and C. It is a array of characters, and it is terminated by something called the null terminating character. So null terminating characters. This character. So this is mandatory in strings mainly because this is the end of a string. So say the function print definition. What is this? also manually assign the termination. Just do zero, and it works perfectly fine because the null condition you can manually assign, or you can just let the compiler automatically assign. Okay, so one thing to be very careful while working with C. So if I have a variable like a and I don't know if it works. If it's the same case in modern compilers, but in old compilers, a random value was given to any variable without a specified redundancy. We'll learn about arrays and string in details in a little while, but before that, I will show you this. Okay, so you can see that the value for a random number is a okay, so the variable for a random number is its value manually because we didn't specify the value manually. Whatever then the loop won't work, and you'll be wondering uh, why I'm getting an error. This might be because you just forgot to initialize the variable and it got a random value from the memory. So that's the basic, and I want to show you about primitive data types in C. So data float. So float B. This is used to store a floating point character. Uh, yes. Okay. Yeah, it is a floating point character, and you can see the value is 123.123.001. The compiler automatically assigns some value. My site, so if we just type convert it to in just because okay, now it works. So you have to manually typecast the value in string if we just want to take the an integer, if you want to take it as an integer. Okay, so there are other basic data types. So there are primitive data types. Okay, you can see boolean, char, short, and long, float, and double. Okay, so in most cases we won't be using the these data types very often, so not demonstrating them. But if you want to read about them, you can um, just Google it and read about it. Next thing I want to cover is arrays. So to quickly cover arrays, then we'll jump to string and we'll cover the statement, the for loop, and finally we'll include the pointers, which is a big deal because people are scared of pointers. They get very confused while talking about them. Uh, so let's just quickly cover it. So let's draw sort of a box in here. Okay, and just divide it. So say this is our computer memory. This. So yeah, so imagine this is a memory, and each individual memory each individual block in memory has a specific address. You see x1, f, and 0, x12, whatever. So array is a block that stores is a data structure that stores the data, stores the same kind of data in blocks like this. So you can just specify the size, and this is 1, 2, 3, 4, 5. So say this is the data, and it is stored in a block in our memory. So to take an analogy, you can assume the houses in a line. So say a house address 312. So that is a house has a address 313, then 314, 315, and 316, like, right? So similarly, each element in array is located adjacent to the previous element in memory. So it is a very useful data structure, mainly because it is the foundation for most of the things that we work on nowadays. And you can just and now let's look at the initialization. Okay, so int it specifies the data type of the array, and then we have to give it an array name. Let's call it a double r, and to specify the size. So in C++, we have to specify the size manually. Now let's run a for loop to take the input. Okay, so you can see we enter the elements in an array. We enter 5 elements, 1, 2, 3, 4, 5, and then we displayed them. So so in array we can't just manually specify the address of each copy, because the address is very long and it's hard to remember. So we use something called indexes. So the first element in the array always is equal to 0. This is a common practice in probably all of the programming languages. That next element has an index of 1, 2, 3, and so on. So the index always starts from 0. So we have initialized and variable I equals 0, and then stick condition. This is the basic follow, and this is similar in most of the programming languages like JavaScript, even, but the Python follow is a bit different. So this classic structure of a follow has three parts: the initialization, the condition, and then the increment or decrement operation, or whatever operation you want to do. So first to initialize a variable I equals 0. I is to specify the index here. Then the condition I less than 5. So I will iterate for 5 times, 0, 1, 2, 3, and 4. And uh, as soon as the value strikes 5, the loop will stop and I plus plus. So the after each iteration, the value of I will get increment by one. And scanf is the C function that is used to take input from the standard input. So the standard input is the keyboard. So when you type a character in the keyboard, it is called the standard input. And scanf is used to take the input from the keyboard, and we have to specify format specifier to specify what type of data will import, and then we pass the reference to the element. So we'll talk about reference and pointers in details for now. uh, Remember that this ampersand refers to reference, and it is used to denote a memory address in memory. So I just start to print. Yes. Okay, give me a second. Do this person key will work because counters and I so you can just visualize that the array is stored as stored in a continuous flow in the memory. So this is the way to visualize it, as the addresses are adjacent. There's a dot of this thing now. Okay. Okay, so so I guess everyone is clear with array. When you have any questions, you can just ask in the workshop channel. I guess the noise cancellation did. Okay, so I'm gonna give it a break. Does anyone have to ask? No questions? Am I audible? Okay, just kidding. Um, so I guess I want to uh, ask my friend and my co-host Siddharth to help me with explaining strings. Siddharth, are you there? Join from phone. Okay, take your time. I guess. Okay, okay. Take your time. We shall continue. Okay, so um, clear clear up this mess. There we go. Okay, so the next thing that I want to cover is strings. So strings are arrays, as you have seen, but so let's say the string H, E, L, L, O, and the next element of string will be a backslash O, which is a null character. So this specifies the ending of this string, and and um, well, and this is important because when we are just reading a stream of data from the standard output to the standard output, to reading is equal to the standard, so the standard output will be the monitor, and we're asking the printf function to print. arguments to a function. But before that, let's take a quick look at the man pages because I would say they are the number one to a man, right? You can see a user command, but this is not for C. This is for the interacting with the terminal, or maybe some other programming language. So if I just type in and two, right? So a manual page may have various sections. So say there's a section for the um, for the shell or maybe for the terminal, and there's a section for C programming, and there might be a section for Go or Rust or whatever. You have to just install the dependency. So a man takes multiple sections, so you can just toggle to the section by changing this number here. So man one is the first section, man two obviously the second section, and there you go. This is the section for standard C library write to a file descriptor. So we'll look at this write function in great detail in our day two workshop, which I'll say is a flagship workshop because we will cover a lot of very important function and which will allow us to interact with the POSIX API. And I will also provide uh, two additional resources, YouTube playlist that will be very beneficial while learning to program in Unix like operating system, and the IEEE POSIX specification where you can find a list of each and every header file, and there you go. So you can just read this man page. This is very helpful to understand how the function do, how to use it and all. And then the thing that I like most about the man pages is this part, the synopsis, because it tells us what the where this function is defined. So which file or which header file we have to include, and it also tells us how we can okay, so what are the arguments and what does it return? So it returns something called size D. This is a special type that is defined in something called the sysless types dot each header file. We'll take a look at it in our the day two workshop. But uh, and it takes three arguments: the write function, a file descriptor. So we'll also look at the file descriptor, what is a count, void, and a size t count. So a size. So we'll take a look at this close look at this function in our how to use this man pages, how to look at various kind of sections. So if I just do man fork is a function that is used to create a new process. So everything in our operating system is a process. So if I just do yes, you will see the process, the process that is currently running, but it doesn't display every process in the UX or something like that, and it displays each and every process and who's running the process. So the user. So this process is a meta root system, and the ID, the process ID, the CPU percentage, the memory percentage, and everything, the TTY, the terminal, and the the process name itself. So you can see so user slash bin slash fish. So this is the current shell that I'm running. I'm running the fish shell, and the already this is a terminal emulator, and the user is AJ Sharma, which is my username, and the PSAUX, that the command I ran, that also ran as a process, and I was uh, the user. So we also have so have a ton of processes. You can see Discord over here. There are processes associated with Discord and how it works in my operating system, and a lot of system processes used by the operating system and the kernel itself. So to create a new process, we use something called a fork function, and while programming a shell, we create a new process to run a command. So it will be particularly very useful while we do our final experiment in the whole day. But for now, though, You can just take a look at its manual page. I won't explain what it is, uh, but you can just learn the use of the main function. So this is not the main page for the C library, right? It is for the new of extension modules. We don't want this. We want the C library. So you can just the main page for, and that this is system for manual standard C library, as you can see. So it requires a file called unistd.h. It returns a PID as a return values of PID is a special type of data type. Maybe it's an unsigned integer data type. So unsigned integer data types only store a positive integer value, not a negative value. So you can say a whole number, and I believe nature number, or maybe whole number. We'll take a look at uh, unsigned integers a bit later, but it is similar to an unsigned integer PID. This is a special data type. So we can typecast it to integer too, and the function takes no argument, so we have void. And you can read about it for creating a new process by duplicating the following process and whatever. We don't really need to go into to read everything here, but you can read about the return value on success and the PID of the child process returned to the parent. So PID is registered process. You can see the ID here, PID there. So it will return ID like this so that we can interact with this. Again, we will look at processes a bit later, but what I'm giving an emphasis on is the man pages. So why they are important and how they can be very handy. And another resource that I want to share is the yeah, the parchment and so this is the standard IEE um, IE specification for POSIX. So POSIX is simultaneously, and POSIX defines a standard operating system interface and environment, including a command interpreter shell, a common utility program, and support applications portability at the source code level. So basically, it is the standards that the operating system has to follow so that the developer can easily access the API and uh, create stuff. So the most important section that I want to highlight is this header section. So you have the base definitions. You can go to the headers, and then you can learn about each and every type of header file. So this is a very great resource that I'm link down below. Uh, you can see the sysless uh, sysless types.h. So I was talking about the types like size, key, and stuff. So it is defined here. You can see PIDT here, the process ID used for process IDs and process groups, and we have P threads for the threads, and the threads are beyond the scope of this course, so we won't cover threads, but you can take a look and read about them online. We have size to use for size. List of objects, we have size to use for count of bytes on an error indication. So basically, size type to store size. We have UID and all. So there are other such files like unistd.h. This is a very important file, contains a lot of function, possibly the fork or the write or read function. I don't remember exactly. We have the terminus.h. This is another important file uh, that is used to alter the terminal configuration. So the terminal structure, it is so structures are like arrays. It is a data structure, but you can store multiple data types. Basically, it's like a dictionary in Python, but there's more to it. It's not like actually a dictionary. It's like well, you can think of it as a dictionary, but it doesn't have a key value pair or stuff like this. But you can just randomly group data, and it has defined some of the flags there, and some of the way to interact with the uh, with the operating system. It uses something called bit flag and bitwise operators, and we'll cover them tomorrow as we'll discuss about the terminal. But these are the resources, and let's move to functions now. But before we do so, I want to see if anybody has any doubt. Uh, I'm going to take a break for a couple of minutes and just have a glass of water. You can ask your doubts in the workshop section. Okay, so I'm back, and I guess there are no doubts, but anyway, this. Okay, so this is the page that I was talking about. I'll give the link down below. Yes, you can see it now. And this is the section that I was talking about, the header section. Okay, so let's move to functions because they are an integral part of programming in C. C doesn't have the object-oriented features like in Java, JavaScript, and stuff. So basically, the role of function gets extended, and we're going to see how to create our own function, how to return types, how to create void functions. So, okay, so here we are. So to create a void function is a special type of function that returns nothing. So just do the void, and then the name of the function is called my function, and the arguments. So for now, let's create a function without any arguments, and all to do is just print something. Oh, I almost forgot to call the function and then delete these things. Printing for a function. So this works. So I just want rocket science. So it's like a void function that returns nothing and just executes the statement. So let's say uh, int function. Let's do a function that adds stuff. So int, it will add two integer numbers, not floating point numbers. So int, and then add the function name. So to take two arguments. So to give an argument, a and b will take the int a, b. So a is the first argument, b is the second argument, and we have to specify the data type. And we will do return a plus b. So whatever the result will return it, and then do 50 plus 50 yes, the colon and call the function here. So add and the two arguments that are specified. So 50, 50, write it. Okay. Oh, yes, no problem. I haven't specified the format specifier. There you go. Okay, we are getting the result. So if we wanted to calculate, say, the area of a square, so the formula for area of square is uh, pi r square. So for pi we'll do 3.14 and we'll just input a radius. Okay, so float area equal radius. Radius times radius. Oh. I have a type of function. Okay. 6j. Area of a circle radius having the radius 5 centimeter f centimeter as will be a floating point. You can do area and then you can do 5 option. Okay. Okay, so you're getting a result, but write a new line here. Okay, so this is the result that we got. So hopefully you get the gist. Okay, so what if we do an int radius here? So it will automatically get typecasted to float. So we will get similar result. There we got the same result because the integer automatically got typecasted to the float when it was first multiplied to 3.14, which is the value of pi. But if we did a int here as a return type, then we to change it here. And then we'll only get 78, we won't get the 5. But I want it to be a floating point. I want everything to be perfect, so I'm just going to go. There we go. Okay, now let's talk about strings and how to take string as a argument. So say, okay, so let's modify this function first. So, Hello there. I'm going to explain in a minute what is this. So just okay. So it brings hello there. So basically, what happens is we use something called pointers. So the first address of this array. So this is an array, right? Hello there. This is the array of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, including the null characters. So it is a array of 12 characters. So we pass the address of the first character. So H, the address of first character, H got passed to this char pointer string. So we'll cover what the pointers, but but for the basic definition, it is used to store the um, it is used to store the address of a variable, so the memory address, and we then printed it using the percentage for string, and then here also in the print function we didn't gave the entirety of the string as an input. We only gave the first uh, the address of the first character that we got, and it automatically printed the string until and unless it encountered the null character. So this is how function works in C, and the thing that I want to show you now is passing references to function. So int a equal to 5, int b equal to 10. So from here, the equivalent f. Okay, so first of all, int f equal to add a plus b. Yeah, a comma b, and do a plus equal 10. So this is basically the shorthand for a equal to a plus 10, and b plus equal 10, which is again the shorthand for b equal to b plus 10. Let's do it times, which means multiply. So we'll just multiply the value of b with 10 and then produce a result. So in result, printf result plus percent e so just pass the value of a and b. So what do you think is gonna happen? Well, obviously, the value will be 5 and value will be 10, while while in this function it will first become 15 and then you will get multiplied by 10, and the total result will get this 115. Okay, one more thing. Let's forget semicolons. Okay. And as expected, we got the result. But so what basically happened is we have our program right here, right? So say there's this area to store the global variable, global variables, and there's this call stack, and this is the heap. So heap is an endless uh, area of memory. So this is the area allocated for a program by the operating system to do task, and this is the free memory that it can access. This becomes more relevant when we cover pointers. Um, for now, mm, so first the main function gets called, and then the add function gets called. So if this is the add function, sorry for the terrible drawing, but if this is the add function, it creates a copy of this a and b variable which gets manipulated. So this main function also have a copy of a and b, and the add has its and this add function has its own copy of a and b. So the add will use his own copy and won't touch main's copy, right? But what if we don't want this behavior? What if we want to modify the behavior the of mains A and B while we give the while we modify while we do calculations in this function? So for that we need to pass something called the reference. So we should pass the address of A and B. And so no pages. Use a pointer here. Here, there's the pointer. As you can see, the value of A and B also got modified. So we pass the memory address as the argument. We use it as a pointer to store the memory address in the pointer. The main function of pointer is to store its memory addresses, and then manipulated this pointer, the values of the pointer. So for this asterisk is used to dereference the pointer. That is, if you just here ways. Okay. And then do a percent p and do a then you can see the address of this variable. This is a very long address. Okay, so okay, so if we do render person d and into style is just to dereference a pointer, that is extract the value that is stored in the pointer. And if we do this and just run our main function, we can get the original value stored in the a, and we later manipulated it. We later manipulated it here by adding a 10 to it for a and multiplying it with a 10 for b. So as you can see, we can magically uh, you know uh, manipulate the values provided as an argument just by using this technique. And this is a very common technique this used in C programming. So I guess there's some doubts in here. Okay, why not percent I guess percent is used to print integer. That's true. For long, yeah, I guess it's used for long. You have to look at the format specifiers. So yeah, that's true. So person D for integers, person F for floats, and I guess person LD as you wrote for long. We don't generally use long. I have never used it. I have programmed for quite a while in C, but never used long. As for the link, I just copy and paste it there, and I will put it in the project repo, or maybe um, in the workshop repo. So it's okay. Explaining pointers is actually a thing because, well, a lot of people say that they cried when first learning about pointers, and they're actually quite complicated. So let me just clear the entire screen and let's go a little bit deep. So say this is your memory. This is our memory. So there is a section to store the global variables. There's a section called the call stack, and I guess JavaScript programmers will be very familiar with this. The Stack Overflow errors and all. The call stack. And this is the heap. So this is like the pool of memory that it's free, and you can use certain functions like malloc to access the heap memory. But we'll take a look at malloc, free, calloc, and all of them a bit later. First, say the first function to be executed is the main function, right? So main will be at the bottom of the stack. So say in the main function, there is this this add function that we're calling. So the main function called the add function. So the so so this call stack, the last element to enter will be the first element to get us. So the last element to enter is add here. So it will be the first element to get us. So it will do its job and then just get terminated. So it will just enter from here and get exited out from here, and we'll do this thing. But for the arguments passed here, it stores a copy of the variable. It creates a new copy of the variable. Say A and B creates its own copy, and main has a separate copy of A and B. So these are two separate entities. Say this is A dash and B dash, and A and B. So what if so if you modify A dash and B dash, say A dash equal to 15 and B dash equal to 100. Even though it is this A dash and B dash is derived from A and B, the value of A and B will be 5 and B will be, I guess we put it 10, I believe 10. So it'll be 10. So so to uh, so to contradict this behavior, we pass the memory address. So what we basically do is, so let me say this part here. Okay. So what it is, we take the address of A and literally say that A and then the address of B, and then just give it to B dash. So we give A's address to A dash, and with the help of pointers, we can manipulate the value of A. So this is our memory, right? So say this is a block where the value of A is stored, right? So say this is A, and the value is 5, right? So if we just have another block in the memories, and this points to this block, and then we can uh, access this block by just by calling a variable like we do in pointer, and then manipulate and then this will lead us to the value of A, and we can manipulate it. So Let's see in action. Okay, so oh, pass the memory address. So pointer stores the address. So pass the memory address and B. There you go. This is the memory address. And now to access the value of A, we have to do the asterisk B syntax. Star B is equal to memory plus A. Okay, so I have a pointer here. It will use the D. Okay, so we get the value of D, right? So what if I do asterisk B is equal to 12? So just increment it by 10 and rerun our code. So asterisk B is 12, that is the pointer location of A using the pointer, but if we now print the value of A itself, we will have first let's put a new line, the value of A, save it. Just run. See, the value of A becomes 12. So what basically happens here is that we have a value of A equal to 2 initially, but we create something called a pointer variable that stores the memory address, and then we pass this a value address of A to this variable B, and then by using this address and using this beautiful piece of syntax, we can manipulate its value and make it uh, 12, which is incremented it by 10, and then print the value. So you can print the value in two ways. You can use this address, the star B, the asterisk B syntax, or you can just use the original variable. So, so this is one of the most uh, important concepts associated with C. We don't usually see pointers in any other language like uh, JavaScript or Python. I believe Rust uses pointers in some capacity, but not in the purest form. I guess it has something of a borrowing model or something related. I saw a video on it on Hotchkiss, but I haven't ever tried Rust, so I don't know about it. Anyways, this is how the pointers work. I hope this is clear, and let's see if anyone has doubt the pointers. Okay, so currently clear. Okay, that's great. That's great. Okay, so okay. So a while ago we were looking at passing a string as an argument. So if we just take a look back at this, you can see char star s. So this type of this pointer will be char, and then it will just store the first address of this first element. So if I just do something like what's my function? My function and okay, so it will store the address of this age, this first element in first element in this pointer over here, and then we'll iterate through the memory until and unless we encounter a null character. So this is the basic concept of pointers. Okay, okay. So standard lib.h has uh, defined a few important functions: malloc, free, calloc, realloc, and realloc array. So I won't cover each and every one of them, but I want to just look at the basic functions. Say for instance, malloc and free for today. The malloc function allocates size, bytes, and returns a pointer to the allocated memory shared size is single and allocating a unique pointer value that later in successfully passed to free. Okay, so so again, let's just draw our basic structure. These are the global variables. This is tag that is allocated by the operating system, and this is a heap. So this is like endless memory. You can just access it, right? So just to so the stack in some way can access this memory, which well, this can be disastrous too if we just use too much of memory or just keep on allocating memory without freeing it. We will eventually get a memory leaks, and this is why C programming is so error prone. But again, this is a very powerful asset, and, and well, the modern programming languages implement it in great capacity, like the concept of vectors and new string objects they find in C. Under the hood, they use this technique to reallocate memory using the realloc function, and reallocating memory for a string using realloc is a very common practice in C. So let's see how can we manually allocate use the memory in the heap to our advantage. So first we need this header file standard lib.h. Here. Standard lib.h. And then we need this. Okay, we need to specify the size and it will return us a void pointer. That's good. Let's specify the size. Okay. Let's do char ptr. Let's just typecast this pointer to char pointer. So pointers have types depending on the data that we're storing. So a void pointer can be casted to any type. So if we want to the string, we can use the char pointer and then well, and then whatever size we want. Let's see. For size, you need this sys types each header file to just specify the size. And then we specify a size over here. Okay. Size of, we can use the size of here, and then size of char times 10. Okay, so we have taken the size of char and then multiplied by 10, so it will be like 10 times the size of a character. So we can store 10 characters in here. So So now let's iterate through this memory. Hope I have defined that is where I need to define I int I, and then we'll pass the value of I, and then I guess this will work. This maybe this one. This paste in here. Size of chart, can just go 10. I hope I'm doing this right. Wait. Okay. Okay. Yes. Wait. Rather than moving the chart, it's first trying with int, and then we'll move the chart. Okay. Let me just add the new line character so that here I can see limit. Okay. So we printed 1 to 10 using pointers. So basically what we did is we allocated a memory in the heap, and then it returned as a void pointer that we converted into an int pointer, and then for to access the element in the pointer, we just did ptri. This is an alternative syntax to access the array that we have created using pointers. So we can just do ptr and then the index, and then just add provide the value, and then just print them. So rather than using dereference each and every time or pointer arithmetic, we can simply use the text to uh, to access the memory address of the array. So we have any questions? All right. Yes. No questions till now. Okay. It looks clear. All right. Let's move on here. Okay, so it's always a good practice to uh, clear up the memory that we use, because well, if we allocate memory in a loop, this might result in a memory leak or something like that. So we just use the free function. Just remove everything from the memory, and so we get the same result, but it's a lot safe now, because there is no chance for a memory leak. And a lot of times you just forget to free up the memory, and then in a loop you keep on reallocating memory, and then you get errors. Okay, let's try something else. Let's go to my pages. So we have free, we have real. Okay, so real is very similar. Just re changes the size, so you can just so people to, yeah, we can see the last, but for now I want to delete them, because I want to demonstrate something else. Delete all of this. Okay. Okay, so real is used to real free. What we do, damn it, it star real and ptr, of course, is this pointer, and as of in times this is decrease the size. Or is it valid syntax? I don't know. I haven't used this in a while. Just test it. Okay, it's valid. It's valid syntax. Now let's just use it. Okay. Alright. So same thing. Just you just reassign I less than 5. Percent new line character, and it's always a good practice to free the memory. Zero, 1, 2, 3, 4 direct for 14 implemented to this one. PTI equal 0, 1, 2, 3. Here's some basic 3.5. That's the problem. We seem to have a little problem while getting it. Oh yeah. Okay. PTR. Okay, we're getting the correct input now. So what if we just try to print Families, yes. Okay, okay, so okay, so um, 15, just change the size, and then we just rewrite. There we go. Okay, so it can access more elements while um, okay, so it can access more elements because it is a continuous block of memory. The I is getting implemented and it's just going to the next block, so we can access the next block with the first pointer itself because it gives a result of first pointer and then we keep on incrementing. Uh, but if we want to increase the size, then we can do it by realloc. But if we don't have this statement in here, just this. There we go, we get an error. But because of realloc, we can, of course, go and just run it and we get 15 elements now. The reason that the size doesn't shrink down while we just try to reallocate it reallocate less memory is because we only get the address of the first element and then we go and implement go to the next element. Uh, so the adjacent elements get uh, so the adjacent elements get the value of get the new value. But in case of but in case of uh, but in case of not allocating the memory, we just get this error that says malloc corrupted top size job one name terminated. Okay, so we get this size not defined error. We just have to read it. So you can see this can be very useful in various different sectors, but this most used while working with strings because in C we can dynamically allocate memory using these techniques. But say say we have a string and we allocated it, I don't know, 20. We allocated 20 to it, right? So we sort of provided the size of 20 so there's a chance that our string might get larger than 20 characters. So for that we can use the reallocate function to increase the size size. You will see it being used in other places as well, but this is by far the most common use case that I have while working on it. And the thing that I want to take away from this is the use of this man page because I didn't knew the syntax of this functions because I haven't used them in a while, but I just took a look at the man page, took a look at the synopsis, and the return types and the errors that I can give them. I could use them quite easily to accomplish what I want. So the real deal is this a manual page. The This is the teacher. This will allow you to unlock a lot of possibilities by learning about a lot of functions without following a lengthy tutorial or something like that, right? Okay, so let me just go to the page. Let's see if anyone has doubt. Manual speech begin. We have to go to 3 pointer. Okay, so we're having a discussion in here. Okay, so I guess it's enough for today. We'll continue tomorrow with the library function, and today was a basic introduction to maybe just a review or a reminder for those who haven't capture the syntax in a while, and tomorrow we can learn about the functions, and then uh, in the third day we'll create a project, and I guess this that will be the most important day of the week, because the project is you know it looks awesome. I just show it to you again. DC cell I have named it a DC cell. It's almost complete. I only have to create some built-in functions in the DC cell, and here we go. This is our own shell, and type in commands and all. And let's actually this lists everything in the directory. The change directory doesn't work currently because uh, it doesn't come as a standard system call. So I have to manually implement it, manually write the parser for it. I will write it as a part of the built-in functions. But yeah, this is the basic demonstration. So let's look at the source code of this. Index.c. I think we'll get this write function, and then we'll learn about write function tomorrow. What the standard out will go in great detail about them. And so let's see. So we have this parse, and then you show this in this file where we can execute the using the for function. We can execute the command and uh, read the read the standard input and tweak it to our heart content so that we can use it with the yes exec VP function, which is used to execute this shell commands. So the main goal with this shell is we can maintain this this fork. For the sake of simplicity, we won't be using pipes. Yeah, this is the basic structure of a program, and we learn how to create this spreadsheet in 100 days. Yeah, I guess that's all I have to say.